Chapter 4 is where we take the derivatives and all the rules and we now start applying them. So in this chapter, we're going to revisit maxes and mins, how to find the maximum of this, how to find the minimum of this, how to do left and right and up and down, how to find out if it's speeding up or slowing down or things like that. It's all the uses of the derivative. And then that finishes derivatives. So chapter 4 is the last chapter of derivatives. And then chapter 5 in October, we'll start with the antiderivative. So we're really marching along quite quickly. So today we're going to talk about absolute versus relative, or global and local extrema and extreme value theorem. So as with any of our theorems, like we have the IVT, and we talked about the squeeze theorem so far. So we've had the intermediate value theorem, the squeeze theorem. Now we're doing the extreme value theorem. Continuity is required, and you must explicitly state that your function is continuous. That's always part of it. Anytime you cite a theorem, make sure you state since f of x is continuous. Okay. And then also make sure you identify the interval and whether or not the endpoints are included or not. That's going to be important as well. All right, if you have a continuous function on an interval that includes endpoints, you are guaranteed, the EVT guarantees all extremes. So extreme being you guaranteed at least one maximum and at least one minimum, and you're guaranteed one single absolute and one single minimum and maximum. So you're guaranteed at least one of the locals and then at least and exactly one absolute. Okay, so here are just examples of continuous functions. If it's not continuous, you are not guaranteed that. So over like the tangent function, tangent's not continuous. So it depends on the interval that you are given. If your interval contains a continuous part of tangent, then you're fine. But if the interval contains an asymptote of tangent, then you're not fine. So it all depends on where the interval is. So even if the function does have some discontinuities, it depends on what interval you're looking at. So the EVT guarantees you can find a max and you can find a min for every continuous function. Okay, so here's just a sample of a couple things. You need to make sure you're checking all the important parts. We call those critical values. So the obvious critical values are where the slope is 0. And so in this case, it happens twice. Those are considered critical points. But so is the cusp. And in that situation, the slope is 1 over 0, and that's also considered a critical point. So you're going to take your derivative and set it equal to 0 and 1 over 0 to find all of the points. But also part of the critical points are the endpoints. So you'll have endpoint A and endpoint B. And those are also considered candidates. So all 5 of those would be what we call candidates for the absolute. So they could be the absolute max, they could be the absolute min, they're all candidates. On the next one, I've got filled in like the official definition. So words like absolute and local, you should be familiar with those words from last year as well. Okay, we can also call them global and relative, that also works. Absolute means global. Local and or means relative. Okay, so here we go. This is the definition. Critical point is a place where f prime either equals 0 or f prime does not exist. Okay, so you're going to set derivative equal to 0. And you're going to set the derivative equal to 1 over 0. That will help you find any corners or cusps. All right, so again, just pulling in the language, this is the candidate's test. The candidate says identify all the candidates. So the candidates include, and you may remember from last year, the most often missed things are the endpoints. People forget to check the endpoints. You remember to check your endpoints. The endpoints are candidates just as much as the horizontal tangents and just as much as the places where there's corners or cusps. Okay, so don't forget. Okay, that's this one. And at each endpoint. Okay, super important. All right, so here we go. Let's just quick practice. Find the absolute minimum and max on the interval. So I always just check my endpoints first. So I want to do what f of -1 is, and I'd like to do what f of 2 is. So these are my two endpoints, which are candidates for being a max or a min. F of -1 is 3 times -1 to the 2/3. -1 to the 2/3 means the cube root of -1 squared. Okay, so that's 3 times 1. And then 3 times 2 to the 2/3 is the cube root of 2 squared. So that'll be 3 times the cube root of 4. So between those two, we already have, one of them is smaller than the other. So those are our candidates so far. And then our other candidates are going to be the critical points, where we're going to take f prime and we'll do the math on that. So f prime would be taking the derivative, so that'll be 2x to the -1/3, in other words, 2 over cube root of x. So setting that equal to 0 gives me no additional answers. So 2 over the cube root of x implies that there are no other answers. And then setting that equal to 1 over 0 gives me the additional answer of x equals 0. So that's the additional candidate. So then I want to go back and figure out what f of 0 is. And f of 0 plugged back into the original function is 3 times 0 to the 2/3, which is 0. So now, according to the candidates test, I've checked all the candidates, and
Thanks for
oh, she is on Wilderness Challenge. Should we just, who would like?
Did anyone want a
How about
mulch?
give it to, see if Mrs. Reedfeld would
Miss
like
Reedfeld?
Yeah.
Maybe Miss Dorwell should want.
Yeah, that good. Who's it from? Is it from like her tennis secret? Okay, bummer. All right, so then we are able to find the min and the max. And so this one is the absolute min, because 0 is the lowest number. And then this one is the absolute max, because multiplying 3 by the cube root of 4 is going to make it bigger. So the minimum value is 0. The absolute maximum value is 3 cube root 4. On a multiple choice, it's really interesting because on a multiple choice, they may have one of the options be the number 2. And I've seen students pick number 2 as the absolute max, but that's where the absolute max is happening, but it's not what the absolute max is. The absolute max is the 3 cube root 4, so you have to make sure you pick the right thing. Don't do all the work and then accidentally pick the wrong one. All right, this is our last problem. Find the extreme values of this particular function. All right, we do have a domain that we're going to have to think about here because there are certain numbers we cannot put in. Can you give me some examples of what we, either tell me what we can put in or tell me what we can't put in? Okay, can't put in 3. Okay. Can I put in anything greater than 3? Okay, so it has to be less than 3. Anything else? Oops. Everything it needs to be. And it has to be greater than -3, because like you can't even put in -3, because if you put in -3 and square it, you'll get 0 in the denominator. So this is going to be between -3 and +3. So then when I go to check my endpoints, there are none, because I don't have any closed interval, so I don't have endpoints that will be part of my candidates. So then I'll go on to the critical points. So f prime of x is going to be -1/2 9 minus x squared to the -3/2 times -2x. So I think if I'm evaluating all that right, my numerator and my denominator, I believe, are that. So the negatives simplify, the x stays in the numerator, the 2's reduce, the 2 and the 1/2 reduce. So then we set that expression equal to 0 and undefined. So if I set it equal to 0, the implication, the solution, is that x is 0. So that's one of my candidates. I'm doing 0 over 1, by the way, right? When I set something equal to 0. And then when I set it equal to 1 over 0, and I cross multiply, I get plus or minus 3. However, plus or minus 3 were not part of the original domain, and so I exclude them. And so I only have one candidate, and the candidate that I have happens to be 0. That's the only thing that I have. And so f of 0 then is 1 over the square root of 9 minus 4. Now, I don't know if that's a max yet or a min, but it's my only candidate. We'll be able to tell if it's a max or a min using some of our other tests when we add them, but right now I can't tell if it's going to be a max or a min. But when we check concavity, we'd be able to tell. If we were able to tell if it was changing from a plus to a minus or a minus to a plus, then we'd be able to tell, but for now we can't tell. That's as far as we could get.
So what would we